Today we'll learn how to find slacks and floats of a given network in PERT and CPM. So let us make a simple network. PERT network, it starts with event 1. It starts with event 1 and it ends with event 9. These two are events. One is called starting event and 9 is called ending event. One is starting event of complete project. This is important. It is starting event of complete project, while 9 is ending event of complete project. Why is one starting event of complete project? Because if we look at them very carefully, what is happening? Let us take combination 1 and 2. What is 1? 1 is starting event for A. A is starting over here and A is ending at 2. So 1 is starting and 2 is ending for A. What about C? If we talk of C, 4 becomes starting, 5 becomes ending. If we talk of G, 5 becomes starting, 8 becomes ending. Similarly for A, we had 1 was starting and 2 was ending. So if you go on like this, you will see that 2, 5, 8, 7, 4, 3, 6, they all are playing dual roles. They are ending for someone and they are starting for someone else. But if we look at this event 1 and this event 9, they are playing only one role. One is only starting. It is never an ending event for anyone. You can see it is never an ending event. No one is coming in. No arrow or activity is coming in. So it is never an ending event. Nobody is starting from 9. Nobody is going like this. No events are going out of 9. So 9 is not a starting event for anyone. It is never a starting event for anybody. So what do we learn here? That 1 is starting event of project, 9 is ending event of project. This is a basic PERT network. Now, when we go further and try to see what are the slacks and floats available for the network. Slacks and floats. Okay, so what are slacks? We divide slacks into two. We have head slack and then we have tail slack. And there are three kinds of floats: total float, free float, and independent float. So we have two kinds of slacks and three kinds of floats that we generally study, try to find out. Now, if we go ahead and try and understand, let us say I'll take activity F, or now before we could study these slacks and floats, what we'll do is we'll make a forward pass and a backward pass on this network. A forward pass and a backward pass. During forward pass, what we'll be doing is we'll be adding, and during the backward pass, what we'll be doing is we'll be subtracting. Let us find out what are various paths to go from 1 to 9. I wish to travel from 1 to 9. What are the various paths? Let us have a look. 1, 2, 5, 8, 9. So we have a path ACGK. Then there is another one ACHL. Then there is an ADIL. We have BEIL. We have BFJL. So how many paths in all? 1, 2, 3, 4 and 5. So I have 5 paths in all that can take me from 1 to 9. Let me make a forward pass and a backward pass on these, and then we'll see what are all those. First, let us write all these paths. What were the paths that we identified just now? A, C, G, K. We had A, C, G, K. Then we had A, C, H, L. We had A, C, H and L. Then there was A, D, I, L. A, D, I, L. Then all paths of A are done that are starting with A. Then we had a couple of paths starting with B. We had a BEIL, we have BFJL. So let us write down these paths also. What are those? BEIL, then there is BFJL. So there are 5 paths in all that we have listed. Now let me find out duration of each of these paths. What are their durations? If I take this outer path ACGK, what are its durations? 5 plus 4, 9, 9 and 3, 12 and 2, 14. So duration would be 14 for this path. Similarly, what is the duration for my second path, that is ACHL, A, C, H and L? What would be the duration? 5 and 4, 9 and 7, 16, 16 and 4, 20. So my duration would be 20. Then we have a third path ADIL, 5 and 8, 13, 13 and 4, 5 and 8, 13, 13 and 9, 22 and 4, 26. We have a duration of 26. Then there is this path BEIL, 2 plus 5, 7, 7 and 9, 16 and 4, 20. We have a duration of 20. Then there is another path, last one, BFJL. What is its duration? Its duration is 2 and 1, 3 and 3, 6 and 4, 10 in all. So now that we have found that there are 5 possible paths that take me from 1 to 9, and we also have their durations. Which is the longest duration? It is 26. ADIL 26. So this ADIL 26 is a very important path. This path is called critical path, and this duration is called duration of project. So these two things are very important. ADIL is critical path, 26 is duration of project. And because this ADIL is so important, we'll make certain arrangements so that this path stands out. What are those arrangements? We'll make it double. We'll represent it with a double dash so that it stands out, it is visible clearly, it stands apart from others. A, D, I and L. So this path ADIL is our critical path. Now as we proceed towards slacks and floats, what we need to do is, first we need to make a forward pass and a backward pass. What do we mean by forward pass and backward pass? It is nothing but we'll try to determine what are the various earliest starting times, latest starting times for all these paths. Let us make a forward and a backward pass on this. One important thing, how do I make these forward and backward passes? I'll keep a very close eye on these durations. I will make forward and backward passes in order of these durations, in descending order. Okay. So if I am going in descending order, what will be my priority? First I will solve this path. Second and third you could go with either one because they both are same duration. Then I should be going with this. Fourth number I will be going with this path. Third will take, let's say, this one. And last be this path. So it's just a priority list, an order in which we should make the forward and backward passes. First one, we are going with ADIL. Let us see what do we mean by forward pass and a backward pass. In forward pass, we try to find out what is the earliest possible time that I can finish this project. That too I am starting with 26, the longest one, the critical path. Let us see. If I start this activity A, this is the first activity. Let us start this activity at this very moment of 0. So if I start this at 0, it will take 5 minutes. When will be I there? At 5. Then, in case of D, I am here at 5. I can start right away. So I'll start at 5. It will take me 8 minutes or 8 days or 8 hours, whatever time units we are considering. So 5 plus 8 would give me a 13. Then similarly I travel on I, that is 13 plus 9. 13 plus 9 would give me a 22. Then finally we have a 22 plus 24 would give me a 26. So this is a forward pass. What I have done is I have made a forward pass on my longest duration path. Now, if I start at earliest possible time, that is 0, I'll be here at 5, 5 and 8, 13, 13 and 9, 22, 22 and 4, 26. If I go with earliest time without wasting any time, I can finish this task in 26 days. But as we know that this 26 is critical, so I do not have any leverage. This path does not have any leverage. This path cannot waste any time because it is stuck at 26. So this path has to be finished under all circumstances by 26. Now, a forward pass revealed 0 plus 5, 5, 5 and 8, 13, 13 and 9, 22, 22 and 4, 26. This 26 was for forward path. Now I am making a backward pass. Backward pass, I have to finish it by 26. 26 minus 4. See, in forward pass I was adding the durations because I was seeing if I start at 0, I'll be there at 5. If I start at 5, I'll be there at 13. But this time what I'm doing is I'm backtracking myself. It is a reverse pass, backward pass. So because I have to finish this task by 26, when should I start task L, activity L? If you have to finish it at 26, you know it takes 4 days, minutes, time units, whatever it is. So 26 minus 4, you definitely have to start it by 22. 26 minus 4, 22. Now if you have to get here by 22, if you have to start L by 22, then I should be completed by 22. Now in order to complete I by 22, it takes 9, so 22 minus 9, I definitely should be started by 13. Similarly, 13 minus 8 would give me a 5. 5 minus 5 would give me a 0. So this was a forward pass and a backward pass at my critical path, ADIL. So yes, I am done with forward and backward pass on ADIL. Now let us start with our second path. We identified that ACHL is the longest duration. So we'll start with this path, ACHL. Let us start with ACHL. Where is ACHL? Here we see A, C, H and L. Let us start with our forward pass. Now remember, this 0, this is for forward pass. You should never think or see this 0. In forward pass, this 5 is your forward pass 5. This 5 belongs to backward pass. So if we write it as this, so first digit is for first number time duration is for forward pass, second one is for backward pass. Now because right now we are making only a forward pass, so I'll be looking at this 0 and this 5. I will never be looking at this 0 and this 5 during a forward pass. Let us start, we'll learn it with time. If I start at 0, 0 and 5, what I'm doing, I'm looking at path ACHL. This is path ACHL. If I start at 0, 0 plus 5 is 5. 5 plus 4 should give me a 9. Then 9 plus 7 should give me a 16. Now we have a controversy. Some time back you wrote 22. Now you want 9 plus 7, 16. What do we do with this controversy? What we'll do is, we'll frame a rule during forward pass. During forward pass, if you are stuck in a situation where two conflicting durations are available, you always take the larger duration. And who is the larger one over here? 16 or 22? It is 22. So what we'll do is, we'll take, yes, exactly, we'll take 22, we'll not take 16, rather we'll take 22. So in this case, where we had a controversy between 16 and 22, over here I'll take exactly what we'll take is, 9 and 7. I'll not take 16, rather I'll take 22 only. 16 will not be coming over here. So 9 plus 7 is 16, but we cannot take 16 because 22 is larger during a forward pass. So we'll go ahead with 22 only. Then this 22 plus 4. 22 plus 4 would give me a 26 and I reach here. Fine. Now forward pass is done on ACHL. Now let us start for the backward pass on ACHL. Where is our ACHL? ACHL. Let us start with our backward pass. If I start at 20, if I have to end at 26, 26 minus 4, I have to start at 22. This we talked earlier also. Now if I have to end H at 22, then what should I do? 22, I have to end it. When should I start H? 22 minus 7, that is exactly 22 minus 7, 15. Fine. Then 15 minus 4 would give me 11. But 11 or 5, that is a confusion. Should I put 11 or should I put a 5? So there is no confusion. Just as we framed that rule for forward pass, we have a similar rule for backward pass. During a backward pass, if you come across a situation where there are two conflicting times, you always take the smaller of the durations. As simple as that. So in this case, you are stuck with two durations. One is 15 minus 4, 11. So should I put a 11 or should I put a 5? No doubts at all. It will always be a 5. Alright. Then we have 5 minus 5, 0. So let us have a look at this path quickly once again. 0 plus 5, 5. 5 plus 4, 9. 9 plus 7, 16. But rather I'll put 22 because in a forward pass I take for the larger value. Now I have 22 over here, 22 plus 4, 26. This was about forward pass on ACHL. Now let me jump to this 26. Now as I am on this 26, therefore I should be making a backward pass. 26 minus 4, 22. 22 minus 7, 15. 15 minus 4, 11. No. In a backward pass, the smaller of the value survives. So it will not be 11, rather it will be a 5. 5 minus 5, 0. So we are through with both the forward pass and backward pass on ACHL. Now let us move to BEIL. BEIL. Where do we have BEIL? B, E, I and L. This is the path where we need to go. Let us move. This time we'll make a quick pass. 0 plus 2. 2. 2 plus 5. 7. No, 7 cannot come. We'll have a 13 over here because it is a larger value. 13 plus 9 is 22. Very well. 22 plus 4 is 26. Done. Now let me start with backward pass. See, 0 plus 2, 2, 2 plus 5, 7, 7 cannot come, 13 will come because it is the larger value. Larger one wins the game in a forward pass. Then you have 13 plus 9, 22, 22 plus 4, 26. Jump to this 26, 26 minus 4, 22, 22 minus 9, 13. 13 minus 5 will give me an 8. And then this 8 minus 2 will give me a 6, but no, I already have a 0. That 0 will win the game. So I'm through with this path BEIL also. Who is next in our list? This 12, 4th. So let us now go ahead with this path ACGK. A, C, G and K. ACGK. 0 plus 5, 5. 5 plus 4, 9. 9 plus 3, 12. I should have a 12 over here. Then 12 plus 2, 14. No, 14 cannot come. I will have a 26 over here. So forward pass is done. Jump to the backward pass. 26. 26 minus 2. 24. 24 minus 3. 21. No, 21 cannot come. It will be a 15. 15 minus 4 and so 11. 11 cannot come. It will be a 5. Because 5 is a smaller value, 5 minus 5 is 0. So we are quickly through this path ACGK. It is a very fast process. We are taking it slowly because it is the first time that we are doing this. Now, last path is BFJL. BFJL. So how do we go? 0 and 2. 2. 2 plus 1. I should get a 3 over here. And then 3 plus 3, 3 plus 3, 6. No, in forward pass 22 is the valid number. 22 plus 4 is 26. Done with forward pass, jump to backward pass. 26. 26 minus 4, 22. 22 minus 3. There should be a 19 during the backward pass. Then 19 minus 1 would be 18. No, in a backward pass 8 is a better number. 8 minus 2 is 6. Again, no, 6, 0 is a better number. So now, after this journey of forward pass and backward pass on all 5 paths, now we can go ahead and find out slacks and floats for all respective activities. Alright. So for the purpose, we'll make a table. Now let us see what are these things called slacks and floats. For the purpose, we'll just pick, let's say, activity F. It will be easier to understand using this activity. What is this activity? F 1, 3, 6, 2 and 8, 3 and 19. So if we look from the perspective of only activity F, this is head of this activity. This is head of this activity. Why? Because we have an arrow over here. This is the tail of this activity. So whatever difference in durations do you have over here, that is our head slack. What are the differences that we have over here? If we look at these times, we have a 19 and a 3. So 19 minus 3 gives me a 16. I have an 8 and a 2. 8 minus 2 will give me a 6. It is different, so it will always be larger minus smallest. So we have a difference of 16 and difference of 6. These values of 16 and 6 are what we call head slack and tail slack. So let us go ahead and fill in these values for F. Where is F? What is the head slack for F? We just saw it. It is 19 minus 3, that is 16. So what is the head slack? Because this is the head. This is the head of this. So what will be the head slack? It is 16. Such a simple measure. All you need to do is make a forward pass, a backward pass, and the resultant numbers will give you your required head slack. What is it? 16. Now where is the tail for F? Tail is over here at 3. What are the differences in times? 8 and 2, that is 6. So the 6 becomes our tail slack for F. What is the tail slack? It is 6. Was that easy? Very good. Now, what about total float? In total float, look at these times very carefully. This is the maximum possible time that F can last for. This is the latest finish time. And 2 is the earliest possible time where F can touch this network. So this is the earliest start time. What are the differences in these two? 19 minus 2, 17. So what about total float? Total float is nothing but differences in extremes. 19 minus 2 minus the duration. Can we have a formula for total float? Total float is equal to latest finish time minus earliest start time minus duration. This is our formula for total float. So yes, we can go ahead and we can find out total float. What is the total float for this activity F? It is the latest finish time minus earliest start time minus its duration. So what do we get? We get 19 minus 2 minus 1. 19 minus 2 is 17 minus 1 is 16. So these are our durations. So what is our total float? Total float would be 16. Done? Then we have free float. I'll just put these formula over here for our reference. What was total float? That we just put right now. Total float is equal to latest finish time minus earliest start time minus duration. Can that be done? What is free float? Free float is total float minus head slack. As simple as that. We have our total float calculated. We have our head slack calculated. Just go ahead and find value of 16 minus 16. How much that would be? 16 minus 16 would be a 0. And lastly, we have formula for independent float. What is formula for independent float? It is free float that you just found out. Free float minus tail slack. This is your tail slack. So what will be tail slack for f? It would be free float minus tail slack. 0 minus 6. So 0 minus 6 would give me a minus 6. Remember, only independent float can be negative. It is not necessary that it will be negative, but this is the only leverage that can ever be negative. No other leverage made via head float, tail float, head slack, tail slack, total float, free float can be negative. Only independent float can be negative. If you have a negative in this area ever, you have done something wrong. So just go ahead and rectify the errors. Now, in any case, we're done with F. Now we'll bring some other activity. Let's say C. We'll take activity C. All these numbers we'll learn with activity C. Now, a very quick one. Can we have head slack for this activity C? Where is the head? Here is the head. 15 minus 9. How much do we get? 15 minus 9. For C, head slack would be 6. Perfect. Then we have tail slack over here. This is the tail. Whatever difference we have is tail slack. How much difference do we have over here? It is 5 minus 5. So we get 0. So what is the tail slack for C? 0. What is the head slack for C? It is 6. Next measure that we have is total float. Total float is latest finish time minus earliest start time minus duration. Last time, first time, duration. 15 minus 5, 10, 10 minus 4, as simple as that. 15 minus 5 minus 4. That would give me a 15 minus 5 is 10, 10 minus 4 is 6. So what do I get? I get a 6 as total float. Done. Then what about free float? It is nothing but total float minus head slack. We already have total float. Let us go ahead and find total float. Total, here it is. Total float minus head slack. 6 minus 6. It would be a 0. Then what is independent float? It is free float minus tail slack. This is free float. This is tail slack. 0 minus 0. How much do we get? 0 minus 0. It will be a 0, as simple as that. So now that we have tried finding slacks and floats for 2 of these activities in a very detailed way, let us try and find out slacks and floats for all remaining activities. Let me take A. 5 minus 5. 5 minus 5 would give me head slack of 0. 0 minus 0 would give me a tail slack of 0. So as far as A is concerned, I have a head slack of 0, a tail slack of 0. Perfect. What about B? Here is B. What about B? In case of B, we have a head slack of 8 minus 2, 6. Head slack is 8 minus 2, 6. Tail slack is 0 minus 0. So we get a head slack of 6 for B and a tail slack of 0. C is already done. What about D? D, you can see it is 13 minus 13, 0. 5 minus 5, 0. For all activities that lie on critical path, we never have any kind of leverage because they are in such a situation that they cannot afford to waste any moment. So no slacks and floats would exist for any of the critical activities. Then we have E. Where is E? We see E is over here. Head slack would be, this is head for E, 4, 13 minus 13 is 0, 8 minus 2 is 6. So head slack is 0, tail slack is 6 exactly. So we have a 0 and a 6 for E. We get a 0 and a 6. Then what do we have? F, I believe we have already done. Then there is G. G, 24 minus 12. A head slack of 12. 15 minus 9. A head slack of 6. 15 minus 9. So we have a head slack of 12 for G and tail slack of, head slack of 12, tail slack of 6. For G we have head slack of 12, tail slack of 6. What about H? In case of H, we see its head is tied to 22, 22, so no slack available at head. At tail we have a slack of 6. So we can say that there is no slack at head, but at tail we have a slack of 6. Then let us jump on to I. Where is I? Here we have I. 22, 22, and so no head slack, no tail slack. As it is, we already know that being a critical activity does not have any kind of leverage. So both things are 0. No head slack, no tail slack for I. What about J? For J we see head is at 7, 22, 22, no head slack. Tail is at 19 and 3, so I can get a tail slack of 16. So I have 22, 22 as head slack of 0 and a tail slack of 16 for J. 0 and 16 we get. 0 and 16. What about K? For K we get 26, 26. No head slack available for K, but there is a huge tail slack of 12, 24 minus 12, 12. So no head slack, but still there is some tail slack of 12 for K. So no head slack, but a good amount of tail slack. And last one is L. L being a critical activity, 26, 26, no head slack, no tail slack. We already know critical activities do not have any kind of slacks. So now that we are through with slacks, let us find out total floats. A. What will be the total float for A? Latest finish time minus earliest start time minus duration. So what do we get? 5 minus 5 minus 0. So in all we get a total float of how much? 5 minus 0 minus 5. Either ways it is 0. So we get a total float available for A of 0. For B it would be 8 minus 0. 8 minus 2. How much? 6. Perfect. We get an 8 minus 0 minus 2, giving me 6. So total float for B is 6. What about D? Total float for D would be 13 minus 5, 8 minus 8, 0. As it is, we know that D is a critical activity, so it won't have any kind of float available. Sorry, it will be a 0. D is 0, 13 minus 5 minus 8. Fine. Then we have E. 13 minus 2, 11, 11 minus 5, exactly 6. What was that? E. For E we get 6 once again. Then F is done. Let us have a look at G. Where is G? Here is G. 24 minus 9, 15, 15 minus 3, 12. So total float for G looks like being 12. 24 minus 9 minus 3. So it will be 12 for G. 12 for G. What about H? We get 22 minus 9 minus 7. That is 6. 22 minus 9 is 15. 13. 13 minus 7 is 6. 22 minus 9, 13. 13 minus 7, 6. So H again has a total float of 6. What about I? Where is I? I is over here. 22 minus 13 minus 9. Does I have any float available? No. 22 minus 13 minus 9. A float of 0, which is obvious. I being a critical activity, it cannot have any kind of slack or float. So I has no float available for it. Fine. There is no float available for it. Then there is J. J has 22 minus 3, 19, 19 minus 3, 16. It is a big float available of 16 for itself. Sorry. Big float of 16. Then let us have a look at K. K has floats of 26 minus 12, 14, 14 minus 2, 12. 26 minus 12 minus 2. So what do we get? 12. So total float for K is 12. Perfect. And last one is L. L being a critical event, we very well know 26 minus 22, 4, 4 minus 4 is 0. As it is, L is a critical activity, so it won't have any float either. So now that we are done with head slack, tail slack and total float, we can find free floats easily. What is free float? Free float is total float minus head slack. Just find out total float, we have it, minus head slack. So we can just go ahead and find total float minus head slack. 0 minus 0. 6 minus 6. 0 minus 0. 6 minus 0. 12 minus 12 is 0. 6 minus 0 for H would give me a 6. Again we have a 0 and 0. 16 minus 0 will give me a 16. 12 minus 0 would give me a 12, and last one would be 0. So done with free floats. Independent float again is very easy. It is simply free float minus tail slack. Free float we have over here minus tail slack. 0 minus 0. How much would it be? 0 minus 0. Then we get 0 minus 0. Then again we have a 0 minus 0. 6 minus 6. 0. This time we have a 0 minus 6, giving me a minus 6. Then there is 6 and 6. 0, 0 and 0, 0, 16 minus 16, 0, 12 minus 12, 0, 0. So these are our slacks and floats. Now, what were our critical activities? They were A, D, I, L. Let me check. A, D, there is an I, L. Have a look at all these activities. All their leverages are 0 because they do not have any liberty. They do not have any kind of slack or float. So for critical activities, all these will always be 0 only. So that was an introduction of slacks and floats. We'll add some more examples so that we can go through these networks very smoothly. Thanks for watching. Bye-bye.